Here we have the conic section representation for the ellipse. And just so like we saw with the parabola, where the parabola can open either up or down or left and right, it has two different forms of the equation. For the parabola, we saw that it was x squared is equal to 4py if it opened up or down. And if it opened left or right, it had the form y squared is equal to 4px. And for the ellipse, we have an ellipse that is kind of stretched left or right, and one that's kind of stretched up or down. And if it's stretched left and right, then it's going to have the form x squared over a squared plus y squared over b squared is equal to 1. And if it's stretched up and down, it's going to have the form x squared over b squared plus y squared over a squared is equal to 1. And the difference between the two is that the a term is the longer axis. So this is going to be the major axis. So if a is under x, it means that the x-axis is going to be the longer axis and the y-axis is going to be the shorter one. And if the a term is under the y squared term, then it says that the y-axis is going to be longer and the x-axis is going to be shorter. So what we have to remember is that whichever term a squared is under, that tells us that that axis is going to be the longer one. So once again, we have a ellipse that's going to be stretched left and right versus one that's going to be stretched up and down. And once again, the form for this ellipse is going to be x squared over a squared plus y squared over b squared equaling to 1, where a is below the x term, which means that the longer side is on the x-axis. And here we have x squared over b squared, b is the shorter axis, x is the shorter axis, plus y squared over a squared is equal to 1. And a squared is below the y term, so the y-axis is the longer axis. So we have names for the longer and the shorter axes. So the major axis is in this case going to be the x-axis because it's the longer one. So the major axis is the x-axis, and its distance is going to be 2a. So a tells us the distance between the center and one of the vertices. So if we want to find the total distance from left to right, it's going to be 2a because a represents the distance from the center to the vertex. So if we want to find the distance of this whole thing, it's going to be 2 times a because both have a distance of a. And then the minor axis is going to be the shorter one. So in this case, it's going to be the y-axis, and it's going to have a distance of 2b. So once again, the distance from here to here is going to be b, and the distance from here to here is going to be b. So the total distance is 2b, and the foci is always going to be on the major axis. The major axis is x, so our two foci are going to be somewhere here. And to find exactly where, we use the equation c squared is equal to a squared minus b squared. And it might be helpful to remember that c squared is equal to the bigger minus the smaller. A is always going to be the bigger number and b is always going to be the smaller number. Once we find c, c tells us the distance from the center to the focus. And same thing on this side. Those two distances are c. So this ellipse has a squared below the y term. So its major axis is going to be the y-axis. And once again, it's going to have a length of 2a. So this distance here is going to be a. This distance here is also going to be a. The length of the minor axis is going to be 2b. And in this case, this is going to be the x-axis. And finally, to find the foci, so this is going to be distance of b. To find the foci, we're going to use the same equation. We're going to say that c squared is equal to a squared minus b squared, where we have the bigger one minus the smaller one. And that'll give us the location of the foci. And the foci is always along the major axis, so in this case, it's going to be the y-axis. So it's going to be somewhere here. And the distance from the center is going to be c. Okay, so now that we got an overview, let's look at a few examples. Here we're asked to find the foci of the ellipse 16x squared plus 9y squared equals to 144 and sketch the graph. It also says identify the major and minor axes. So we're going to rewrite this equation. Okay, so it's not in the form that we want it to be in. We want it to be in the form x squared over a squared plus y squared over b squared is equal to 1, where a and b can be under either x or y depending how it's stretched. So we're going to go ahead and change the form of this equation, and what we're going to do is divide both sides by 144. Because we want the right side to equal to 1. So when we do that, we get 16 divided by 144, which simplifies to 1/9. So we're going to have x squared over 9 plus 9y squared over 144. 9 over 144 simplifies to 1 over 16. So we have y squared over 16, and then 144 divided by itself is just 1, and there we go. Now we have it in the form we want it to be in. So now we identify the a and b term. So because this one's the bigger one, it's going to be the a squared term. So if this is a squared, that means a is equal to 4, because 4 squared is 16. And then if b squared is equal to 9, that means b is equal to 3, because 3 squared is 9. Okay, so we have our a, we have our b, but now we want to find our foci. The important equation that we mentioned before to find the foci was c squared is equal to the bigger one, a squared, minus the smaller one, b squared. So if we plug a and b in, we can find what c is equal to. And c represents the distance from the center to both the foci in either direction. We're going to go ahead and plug in a and b. We get c squared is equal to 4 squared minus 3 squared. C squared is equal to, we have 16 minus 9. 16 minus 9 is 7. And when we take the square root of both sides, we get c is equal to the square root of 7. So now we can go ahead and graph our ellipse. We know that the major axis is the y-axis, so it's going to be stretched up and down. A is 4, so we're going to have the vertices 0, 4 and 0, -4. This is our major axis because it's the longer one. And then the minor axis is the x-axis, which has a distance of 3 from the origin. So this is going to be 3, 0 and -3, 0. We can go ahead and sketch it in now. This is a really rough sketch. And now we can go ahead and put on our foci. Once again, the foci is always going to be on the major axis. It's going to be on the y-axis, and it's going to have a distance of square root of 7 on both sides. So we're going to go up square root of 7 and go down the square root of 7. So those 2 points is going to be 0 square root of 7 and then 0 negative square root of 7, and those are our 2 foci. Alright, let's take a look at another one. We're asked to find an equation for the ellipse with its foci at 0, 2 and 0, negative 2, and the length of the minor axis is 6. So let's go ahead and just make a sketch here. So it's 2 foci at 0, 2, which is on the y-axis, and 0, negative 2. Those are the 2 foci. If the foci is on the y-axis, that tells us that the y-axis is the major axis. So this is the major. And it tells us that the x-axis is going to be the minor. And we're also given that the length of the minor is 6. So if the total length of the minor axis is 6, that means that it was 3 in either direction of the center, because we know that the center is at the origin. If we go 3 this way, we're going to have a vertex at 3, 0. And if we go this way, we're going to have a vertex at negative 3, 0. Okay, so we got our foci and vertices of the minor axis. Now we need to find the vertices of the major axis. This here tells us that B is equal to 3. This here tells us that C is equal to 2. And once again, if we remember our handy equation, C squared is equal to A squared minus B squared. We know C, we know B, we can go ahead and solve for A. So C is 2, 2 squared is 4. We don't know what A is, so we have A squared. Then we have minus B squared, B is 3, 3 squared is 9. So now we'll go ahead and add 9 to both sides of the equation, giving us 13 is equal to A squared. And then taking the square root of both sides, we get A is equal to the square root of 13. Alright, so we're asked to find an equation. We can go ahead and do that now. Our equation is going to be x squared over something plus y squared over something equals 1. So because the major axis is the y-axis, that tells us that the a term is going to go below y. So the term here is going to be a squared. A is the square root of 13, so 13 squared is going to be 13. So here we have a 13. And then that means that our minor axis is the x-axis. B is equal to 3. So 3 squared is going to be our b squared term. So that's going to be 9, because 3 squared is equal to 9. And that's it. This is our equation. Okay, let's look at one more. So this one's going to be a little bit trickier. We're asked to find an equation for the ellipse with the foci on the x-axis. The length of the major axis is 10, and the ellipse passes through the point the square root of 5 and 2. Let's go ahead and make a sketch. It tells us that the foci is on the x-axis. So that tells us that the x-axis has to be the major axis, which means that the y-axis is the minor. And it tells us that the length of the major axis is 10. So the total distance from this vertex to this vertex is going to be 10, which means that each distance from the center is going to be 5. So this vertex here is going to have the coordinate 5, 0. This one's going to be negative 5, 0. And then because this is the major axis, that tells us that A is going to equal the distance from the center to this vertex, which is 5. So that's our A. So now we want to find what B is equal to. So we want to know the distance on the y-axis. And the other information we're given is that the ellipse passes through the point the square root of 5, 2. So we know that this ellipse is going to have the form x squared over a squared, because x is the major axis, so a squared is going to be below the x squared term, plus y squared over b squared is equal to 1. And this point here gives us an x and an y on the ellipse, so we can go ahead and plug in for x and for y. And then now we do know what a is equal to, so we can also plug that in. And then all we're left with is b. So we can go ahead and solve for b by plugging these in. So when we do that, we get the square root of 5 squared over 5 squared plus 2 squared over b squared is equal to 1. The square root of 5 squared is 5. 5 squared is 25. 2 squared is 4. We have our b squared, and all that is equal to 1. So we can go ahead and simplify this fraction here. 5 over 25 is the same thing as 1 over 5. So we have 1/5 here. We'll go ahead and minus 1/5 from both sides. Minus 1/5. This cancels out. And this 1 we can rewrite as being 5 over 5 to get a common denominator. So when we do that, we get 4 over b squared is equal to 4 over 5. We can multiply both sides by 1 over 4. This turns into 1, giving us 1 over b squared is equal to 4 over 20. We can take the inverse of both sides, which will give us b squared is equal to 20 divided by 4. Once we take the inverse, we're going to have 20 over 4. 20 divided by 4 is 5. So we're going to have b squared is equal to 5. And then taking the square root of both sides, we get b is equal to the square root of 5. So now that we know what b is, what a and b are, we can go ahead and write our equation. So our equation is going to be x squared over a squared. A squared is going to be 5 squared, which is 25. Plus y squared over b squared. B is the square root of 5, so when we square that, we get 5. And all that is going to equal to 1. Okay, this one is for you guys to try on your own. So pause the video and find the equation for this ellipse. Otherwise, the answer will be revealed in 5 seconds.